Hello everyone, I hope you're doing well. Now we have to continue with almost the last part of chapter 18. Yesterday we already talked about 2,4-DMP, which is used for texting both aldehyde and ketone, and it will give a orange precipitate. And then we talked about the Tonans reagent, which is specifically used for texting aldehyde and can be used to distinguish the difference between aldehyde and ketone. When aldehyde is texted with Tonans reagent, you will find a silver mirror on the wall of the text tube. And then we talk about the Fehling's solution. Fehling's solution, I hope you still remember, is basically the copper 2 ion in alkaline medium. So what's been doing is the aldehyde, same as the Tonans reagent, the aldehyde will be oxidized to carboxylate ion, and the copper 2 ion will be reduced to copper 1 oxide. So the copper 1 oxide will give an opaque red or orange color of precipitate. Okay, now so let us fill in the blanks together. Fehling's solution is an alkaline solution containing Cu2 plus ions. Okay, alkaline solution containing Cu2 plus ion. Remember, most important part is alkaline Cu2 plus. Okay. Okay. Then let's continue. When warmed with aldehyde, you need heat as well. The Cu2 plus ion acts as an oxidizing agent. The aldehyde is oxidized to carboxylate ion, as I told you, because it is in alkaline medium. So instead of carboxylic acid, carboxylate ions will be formed, while the Cu2 plus ions are reduced to Cu plus, and then the Cu plus will combine with oxide to form Cu2O to give the copper 1 oxide the red precipitate. So the clear blue, like remember, its original color is blue. So when you describe the observation, remember it changes from blue to an opaque red or orange color as precipitate. You can mention any one of the color in the exam. You don't have to write both red or orange color as precipitate, or red or orange precipitate will do. Okay, and the word opaque means not transparent. Okay, you can't see through the solution once the precipitate is formed. Okay, once again, ketone are not oxidized, so the Fehling's solution remains blue when warmed because, as I told you, the ketone is resistant to oxidation. Are you okay with that? And then the last test we are going to talk about will be the iodoform test. Okay, iodoform test. I forgot to tell you the overall equation. Even though it's not required, but I still want you to know it in case if you are interested. So the aldehyde react with the copper 2 ion in alkaline medium to form carboxylate ion plus Cu2O plus water. Okay, you don't have to remember this equation, but you have to understand that we are what happened? You have to understand that we are using it to test for aldehyde. Okay, test for aldehyde with copper 2 ion, and this one will be oxidized to carboxylate ion, but the one that gives the observation will be copper 2 ion is reduced to copper 1 oxide. Okay? Okay with that? Oh, now then I want to talk about the last part of iodoform test. The last part of test, iodoform test. Iodoform test is It's not specifically used for testing aldehyde or ketone. Instead, it's testing for a specific group of atoms. So if your compound contains this group, okay, or this group, if your compound contains any one of them, this iodoform test will give you a positive result, okay? And its positive result is the yellow precipitate. Now I will find you a YouTube clip to show you the iodoform text later, okay? So the text for the specific groups, okay, will be these two lah. The answer is Na secondary alcohol with this group, specifically these two groups, remember, okay? Now the reagent used will be the alkaline solution of iodine, and requires heating, okay? If your compound, I repeat once again, is not for testing aldehyde or ketone, it's for testing a specific group of atoms. The specific groups are this one and this one. Please remember, okay? So understand? And you have to know a little bit about its reaction, because the text will also mention it as well. Now, why do I say that it can be used to testing for this group or this group? Okay. Now you have to know that first. You have this group now. Can you see this group? With the presence of iodine in alkaline medium, these 3 hydrogen will be substituted. This free hydrogen will be substituted by iodine. Can you see that? And then this one will undergo hydrolysis in alkaline medium. Same as Toland's reagent and Fehling's solution, the carboxylate ion will be formed. But the one that gives the yellow precipitate is this one, triiodomethane. Triiodomethane, remember. Okay? So you briefly know the reactions. You have to briefly know the reaction, okay? And then the triiodomethane, the yellow crystal, okay, can be purified and can be identified by the melting point 119 degree, okay? Now then you may wonder, oh, it starts from this group. Why does this group also show a positive result? Because if a compound contains this group, it will be oxidized by iodine in sodium hydroxide to become ketone, because you know that secondary alcohol can be oxidized to ketone as well. So either you start with this one or you start with this one, you will form this as the product, which gives the yellow precipitate. So I will say this iodoform test is specifically used for testing this group and this group, because if you start from this one, it will go all the way to here. If you start this one, it will first oxidize to here and then go all the way to here. So they are the same. Do you understand what I'm saying? 好，那then here is a class practice. Now I want you to try the class practice first. I will make another video to explain this class practice. Okay. But in the meantime, let me do a summary to what I have talked about. Okay. Now I'm talking about the Fehling's solution is used to test specifically for aldehyde but not ketone, same as Toland's reagent. Okay, so the ingredients are the alkaline solution with copper 2 ion. So what's happening is exactly the same as Toland's reagent. Is a redox reaction. The aldehyde is oxidized to carboxylate ion, while the copper 2 ion will be reduced to copper 1 ion in the form of Cu2O, which gives you the red precipitate. Okay, opaque red precipitate means not transparent. Okay, and then the last test you need to know is called iodoform test. Iodoform test is not used for testing aldehyde or ketone. Instead, it's used for testing a specific group of atoms in a compound, okay? No matter what the compound is, maybe the compound is very big, okay, contains 20 carbons, but if it contains this group or this group, okay, it will show a positive result in an iodoform test, okay? The positive result is the yellow precipitate. The ingredient is alkali solution of iodine. Now, if you pay attention, basically we have a Tonans reagent, we have Fehling solution, and we have iodoform test. All of them happen in alkaline medium, and all of them will give carboxylate ion as well. But of course, the carboxylate ion is colorless, so the one that gives the very obvious observable change is not carboxylate ion. For this one, iodoform test, okay, what's happening is you need iodine in alkaline solution, heat, okay? So you can refer to this reaction. When you have this group, it will first undergo substitution reaction. The 3 hydrogen atoms here, can you see that? The 3 hydrogen atoms here will be substituted by iodine. After that, it will undergo hydrolysis in alkaline medium to form carboxylate ion and triiodomethane, which is a yellow precipitate and give you a very obvious observable change in iodoform test, okay? Okay, I will get back to you. Remember to try this question, okay? Now, I will get back to you and then I will give you more worksheet to do tonight, okay? See you when remember to submit your homework Friday, and if you are still if you still haven't submitted your paper, to do it as fast as possible. Even though I haven't started marking it, but I will do it very soon.